Okay, today we will discuss about loop antenna design. Okay, actually we have different type of loop shapes. So square, circular, they have so many types. Today we will discuss about square type loop antenna. Okay, so this type of structure we are designing. Okay, this is nothing but a some cylindrical shape copper wire. Okay, so in HFSS software we are designing this loop antenna. So we are taking 1, 2, 3, 4, 5, 6, 7 cylinders, cylindrical structures. Okay. First of all, I will create. After that, right, and feeding system. Okay, feeding system. We are having two cylinders. Okay, and at the end of the feed, we will give the excitation. Okay, we will see how to give excitation in software. Here we are giving the lumped port excitation. Okay, after creating this type of structure, I will assign these cylinders to a PEC material, perfectly electric conductor. Okay, after creating the loop antenna structure, I'm inserting this structure in a radiation box. Okay, after that, we will add analysis setup and frequency sweep, and we will validate the experiment. After that, we will analyze the experiment, and you can see what are the results we are getting. And here I am generating a loop antenna at 28 megahertz frequency. Okay, so for 28 megahertz frequency, we will see the return loss, VSWR, and radiation pattern of the antenna. Okay, now coming to the HFSS software, initially I am making XY mode. Okay, the plane is in XY plane. Okay, and I am taking I am name it as a loop antenna, and I am taking a cylinder. Okay, and coming to the dimensions of the cylinder, just double click on the create cylinder. Okay, now change the center position. I am changing 0, 0, 0.02. That is the position, and coming to the radius 0.01. I am taking the radius, very small radius, and height will be 1.326. So this is the height of the cylinder. You can see here the cylinder is formed. Okay, and you have to remember, before creating the cylinder, I am making modular units as mm. Okay, now the entire structure is designed in meters. So please remember this point. Okay, just click meter and click OK. How you get this one? Go to modular and units. Just click meters. Okay, now after that you clear the cylinder one and make these dimensions. Next I am creating bottom part. Here I am creating another wire. Okay, so for that purpose I am taking another cylinder. Okay, and I am coming to the dimensions. I am making 0, 0, minus 0.02, and radius will be 0.01, and coming to the height I am taking minus 1.326. Okay, and just click apply. You can see another copper wire will be created at the bottom of the cylinder 1. Okay, and here we have the gap. Here I am giving the feed line. Okay, we will see later how you give the feed line. And I am creating another copper wire here. Okay, so just take another cylinder. Sorry, take another cylinder like this. And coming to the dimensions, here I am taking position 0, 2.692, minus 1.346. This is the position, and coming to the radius, all copper wires are same radius, 0.01, and here height I am taking 2.692. Okay, so just click apply to get okay. You can see here the right side copper wire will be formed. Okay, and now we have to form another copper wire top and bottom. But if you observe, this plane is a ZX plane. Okay, the copper wire must be taken in a ZX plane. So I am changing to ZX or XZ because we are creating like this. Now I am taking another cylinder. Okay, and coming to the dimensions, I am taking 0, 0, 1.346 and radius equal 0.01 and height will be 2.692. Okay, and just click apply, click OK. So here you can see another copper wire will be created. Okay, and now I will create another copper wire at the bottom of the loop antenna. So just take cylinder 5 and change the dimensions, that is 0, 0, minus 1.346 and radius 0.01 and length 2.692. Okay, just click apply, just okay. You can see bottom wire will be created, and now I am creating feed here. So feed is also in XZ plane. So take another cylinder. Okay, and I am changing the dimensions 0, 0, 0.02 and coming to the radius, already 0.01 and height, that is length, minus 1.7743. Okay, and just click apply. Okay, so feed line will be created. You can see feed line will be created. Now you have to create another feed line. So for that purpose, I am taking another cylinder and dimensions I am taking same 0, 0, minus 0.02 and radius 0.01 and height nothing but a length of the wire minus 1.743. Here negative sign we are taking because the copper wire must be in the negative y-axis. Okay, that's why I'm taking minus. You can see here. So negative y-axis, another copper wire will be created. You can see. Okay, here I am giving the feed. Now here I am giving the feed. Okay, so we have to remember one thing. If you observe boundaries, here some gap is there. There is no continuity in the structure, continuity in the loop. Okay. You have smoothen these edges. So how you smoothen these edges? So to smoothen these edges, I will take a spherical type. Taken. You can see. So here there is no continuous boundary. Some gaps will be created between one wire to another wire. So to fill this gap, I am using a spherical type of structure. Okay, I am taking a sphere and I am inserting sphere here. Okay, then we can get the continuous structure. So for that purpose, I am taking a sphere. The sphere will be created. Okay, now I am changing dimensions, that is position 0, 0, 1.346 and radius I am taking 0.01 and just click apply. Okay, you can see where this sphere is formed. So where this sphere is formed. So here the sphere will be created. Okay, now if you unite these two wires and the sphere, then continuous structure will be formed here. Okay, so like that at remaining edges also I am taking sphere type of structures. Okay, So that's why take another sphere. Okay, and change the dimensions 0, 0, sorry, I am taking another 0, 2.692, 1.346, and radius will be 0.01, and just click apply. Okay, and you can see this edge, the sphere will be inserted, and take another sphere. Okay, and change the dimensions 0, 0, minus 1.346, and radius same 0.01. Click apply and see here sphere will be inserted, and another sphere, and change the dimensions 0, 2.692, minus 1.346, and radius 0.01, and just click apply. So other edge sphere will be created, but here also we are getting discontinuous structure. So here and here also we have to insert two spheres. Okay. So coming to the center position 0, 0, 0.02, and radius 0.01, and just click apply. Okay. So another sphere will be created, and next, so create sphere 0, 0, minus 0.02, and radius will be 0.01. Just apply, click OK. So here also continuous structure will be created. Now you have to give the excitation here. Here I am taking the lumped port. So before creating the lumped port, I am uniting all these structures. Okay. So just select all the structures by using control pin, and here we have the unite option. Otherwise you just right click, and you can see the arrange, go to arrange, edit, okay. Now you can see all are connected. If you just click cylinder 1, entire loop will be selected. Entire loop will be selected. Okay. Now you have to assign the material to this loop. Just double click on cylinder 1, vacuum. You go to edit and just click PEC and assign PEC material, and just apply OK. Okay. So the entire loop will be converted to PEC material. So we will check all the remaining are also converted to PEC or not. Cylinder 2. So automatically everything will be converted to PEC material. Okay. Otherwise you can individually, before uniting, you can select on each and each cylinder 2 and assign PEC material, and click on cylinder 3, assign PEC material, like that also. But here, after creating all the cylinders and spheres, I am uniting, and I am assigning the PEC material directly. So how you we assign here? Just click on the cylinder 1 and go to material, edit, and apply PEC. So automatically entire structure will be converted to perfectly electric conductor. Now you have to give the excitation here. So here I am giving excitation in YZ plane, because here I have to give. Okay. So I am taking a sheet. Okay. And coming to the dimensions of this sheet, 0, minus 1.743,